Hello everyone, very good evening one and all. Welcome to Wallah and welcome to the session. Hello 𝐂𝐸𝐧 CSC, good evening. Whoever joined the session, kindly mark your presence and kindly confirm, am I visible and audible? Am I visible and audible, guys? Everything fine? That's great, that's great. So, we are in the fifth lecture of this arrays topic. Today, we are going to discuss this topic stack using array. While in the last class, we have discussed array as a pointer. In the sense, whether we can use array as pointer or not. In the last class, we have clearly discussed that array and pointers are equivalent. Array is equivalent to pointer, but not exactly same. Between array and pointer, there are multiple differences, but in the way we access the elements, how we use an array, in the same way we can use pointer. So, because of that, we can say array and pointer are equivalent. And like how the array name gives the reference, pointer also gives the reference. In that sense, we can say array and pointer are equivalent. But array is a constant pointer, while pointer is variable. And array always point to the base address, while pointer can point to any address. And array will always give the reference of, using array we will access one element, but it can hold multiple elements at any time. But pointer may point to any individual element or the group of elements. And what is the fourth difference? The operations that we can perform on pointers all may not be possible with arrays, right? So, because of these multiple differences, we say both are not exactly same, isn't it? And then today we will discuss about what is a stack. Firstly, what are the operations that we can perform on stack, and stack implementation using an array. Okay. So, everyone, can we start? Please confirm. Can we start today's lecture? Everybody, please confirm. Ashwini Kumar. Yes, DA students also can learn this. Array concept will be useful even for DA aspirants also. But I understand in DA C language may not be used. Instead we may use Python, but concept remains the same. All right. Okay. First of all, what is stack? We know that the organization of data or the representation of data is what said to be data structure, right? Data structure will give you two meanings, that is organization of data and representation of data. And what are different organizations we have? Majorly we say there are two different data structures. One is linear data structure, other is non-linear data structure. In linear data structure, we will get arrays, stack, queue, linked list. Under non-linear data structure, we may get trees, graphs, sets, maps. Right. So, what is a stack means? Firstly, we can say stack is a linear data structure. Stack is linear data structure. Okay. Then, how it is different from other linear data structures? How the stack is different from other linear data structures? In the organization. How? In this data structure, insertion and deletion and access, all operations will take place at only one end of the list, will be performed at one end of the list. And what that one end is? That one end is called top of the stack. Top of the stack. So, insertion, deletion, access we will be doing from top of the stack. So, when you are inserting and deleting from the same end, if this is the list, one end is closed, insertion and deletion we will be doing from single end. Then as you keep inserting the elements will be occupying the list in this manner. So, whatever you insert recently that will be coming up on the top. So, when you want to delete, the recently inserted element only can be deleted. right? Hence, stack is also known as called as what kind of data structure? Last in, first out data structure. What is inserted last, that you will be able to remove first. So stack is also known as what? Last in, first out data structure. And in the stack, insertion operation is termed as push operation. And deletion operation is what said to be pop operation. And access operation is what we call as peek operation. So with respect to stack, we use different terminology like push, pop, peek, right? So this stack you can implement. This stack you can implement either using array or using linked list or using queue. Of course, if we need to implement stack using queue, we require two queues. But as our topic is stack implementation using array, let us focus on that, right? So now, stack implementation using array. Let us focus on this. Before that, let us suppose the size of the stack is 5. Let the size of the stack is 5. And initially, when stack is empty, top of the stack will be -1. Now, if I want to push some value 10 to the stack, yes, let S be the stack. Let S be the stack. So if this is the stack, top value is -1 and I want to insert, means push 10 into the stack. How I insert? I have to make top to 0. That means top is incremented. So top becomes 0 and S of top, when I say value, 10 will be coming. Similarly, if I want to push 20, again top is incremented. So top becomes 1. S of top will be value. In this manner, let's say I have pushed 5 elements, 30, 40 and 50. So I increment top, and insert 30, again I increment, insert 40, again I increment, insert 50. So top is 2 here, top is 3 here, top is 4 here. Now what is the size of the stack? 5, and I have pushed already 5 elements. So will I be able to push any more? No. That means when I try to push further like this, actually it should give me stack is full or overflow message, or overflow message, right? So whenever we are implementing, we have to handle this overflow. When we are pushing, we should check whether there is empty space in the stack or not. Similarly, let's say at this point of time, I pop. Pop means what? What is present at the top of the stack, that is getting removed. So 50 gets removed. Now if I want to pop second time, what should be removed? 40. So top should be decremented after you delete, top should be decremented. Then only top will be 3, isn't it? Again I pop, so this gets deleted and top gets decremented. Again I pop 3 times, so this gets deleted, top will be 1, 20 gets deleted, top will be 0, 10 gets deleted, top will be -1. Now will I be able to delete any more? I have deleted 5 elements. Now if I try deleting the 6th element, I will not be able to, right? Because all the elements got deleted and there are no more elements in the stack now. So whenever I try to delete beyond certain limit, I should get stack is empty notification, or this is what you say, underflow. So when we are pushing, we should handle overflow case when you are popping, and even when you are trying to access, like when you try to perform peak operation also. When you will be able to access? When something exists in the stack, then only you will be able to access. If stack is empty, then you will not be able to access it. Hence, while peak operation, while pop operation, first we should check, are there any elements in the stack or not? That means we should check for empty condition or underflow condition. And when you are pushing, you should check whether there is an empty space or not. Means overflow condition. Do you understand this first? What we have to handle, what operations or what cases we have to handle when you are trying to implement. Do you people understand this or not? Please respond. Please respond, everybody. Meenakshi. Peak means just accessing, not deleting, just accessing what is on the top of the stack. Like you want to print. So what you do when you say peak, what is on the top of the stack, you will get. But pop means you are deleting, means you will be changing the top after pop operation. But while peak operation, top view will not change. Top will be there only, you just access what is in the on the top of the stack. Okay, chalo. Now, how we implement stack using array? Let's say I would like to implement the push function. I would like to implement the push function, and what I am passing, value I am passing. Okay. Now, while you push, you have to check whether there is empty space in the stack or not. If there exists some empty space, then only you will be able to push, right? So, I have to check whether there is an empty space or not. That means overflow or not. If it is not overflow, then only you will be able to insert. Upon certain condition, I say stack is full or overflow. What condition we will see later? Return. If it is not overflow, if it is not overflow means else, then I will be able to insert. When I can insert? As I said, if top is equal to -1, I will not be able to insert. I have to increment the top. After I increment in the stack, I can insert. Right. So, what I do? Let S be the top of the stack. Let me increment the top. Let me increment the top, and then in that index I am inserting. So, it is pre-increment. What I am inserting? Value. And return, because insertion is done. Now, let I have taken the stack as an array. Let the maximum size is equal to 5. This is array S. Initially top is equal to -1. Now, let I would like to insert 10. So, push of 10 function I am calling. So, this function is called. I know, at least now I know there is a space in the stack. So, let's say if condition is false, what I have written, what I have to write, I don't know still. Let us analyze and write. Okay, assume if condition is false, means there is stack space. So, S of plus top. So, top becomes 0 and S of 0 is equal to 10. Again I am calling this function. If is false, s of plus plus top becomes 1, s of 1 is equal to 20. In this way, I am pushing 30, 40, 50. 5 elements I have pushed. So, top becomes 2, 30 is inserted. 3, 40 is inserted. 4, 50 is inserted. Now, if I try to push one more element, now actually I want stack is full or overflow. That means upon what top value I should not increment it further and I should print overflow. So what should be the condition I have to write here? If top is minus 1, not overflow, 0 not overflow, 1 not overflow, 2, 3 not overflow. When top is equal to 4, as I have taken the size as 5, when top equal to 4, it is overflow. But what if I take the size as n? Top is equal to n minus 1. So, what I have to write here? If top is equal to size minus 1, that means it is overflow. You will not be able to push anymore. Right? Now, let's see pop. When you will be able to pop? When something exists. When something exists. Let's say upon certain condition, I will not be able to pop and I should print stack is empty or stack underflow. What condition to write? Let us analyze and write. Let us analyze and write. Else. Else. What I should do? I have to return what is on the top of the stack. And top should be decremented. So what I can write? Return s of top. After you return, top must be decremented. That's it. So, I am having 5 values 10, 20, 30, 40, 50. Top value currently 4. Now, when I call pop, I know it is not empty. So, return top, s of top, and then top will be decremented. That means logically we are assuming that the value at top is erased, but it is not actually getting erased. That is what the drawback of arrays. Static memory allocation. But how we are assuming? Because we move this index top. It's a logical assumption that the value which exists there is getting removed. In the array implementation, that is the case. So, 50 got deleted. Again I pop. 40 got deleted. Again I pop. 30 got deleted, again pop, 20, again you pop, 10. So 40 got deleted, top reaches to 2. 30 got deleted, top becomes 1. 20 got deleted, top becomes 0. 10, top reaches -1. Right. Now will I be able to delete any more? No. That means after certain deletions, I should get the underflow message. When the top is equal to -1, when the top is equal to -1, that means there are no elements in the stack, so it is giving me underflow message. Underflow message. Do you understand this? How I am writing the code? Everybody? Good. Now, what is peak operation? Peak operation is very simple. It is just a kind of display. What is at the top of the stack? What is at the top of the stack? Means it is simply print S of top. That's it. Okay. Now let me write main function. Let me write main function like hash include stdio.h. Now I am taking this stack and top as global variables. Int S of, as array I cannot declare without size, so I am giving some size as 100 and size as let's say size and then top. Top I am defining as -1. Now in the main function, I am taking first the size. Printf enter the size of stack. And scan it. So let's say here I am entering my size, my stack size. Okay, that may be 5, 10, whatever. Now I may want to perform push operation or pop operation or peak operation. So I am taking the choice int ch and I am taking the choice like what operation you want to perform. So printf enter 1 for push operation, 2 for pop operation, 3 for peak operation. let us take the choice. So scan choice. Now in the switch I can call these functions. Case 1 I have given for push. So if I want to push, I require value what I wanted to push, isn't it? So let us take value. So here I will ask print enter value to push, to be pushed. Enter value to be pushed and scan it. Scan it. And now call this push function by passing value as argument. Break. So if you want to push 5 elements, every time I have to give this. So if I need to do this every time, I have to write it in the loop. I have to actually write it in the loop. Like I might take while loop, while you enter 0. Like you can take another variable, like, or you say I might take some variable char interested is equal to s. I am writing while interested is equal to yes. While interested is equal to yes. Under while I am writing all this, right? So at the end I will ask for the interest. Like one time I have done push operation, I will be asking, are you interested to do one more operation? If you say yes, the loop repeats. If you type n, no, I mean like n, then the loop will be over. So how many times you want to perform, those many times you can keep on entering while. Okay. And now case 2 I would like to do for pop operation. So I can simply print the popped value is %d, pop, and case 3 is peak operation. You can simply, the element at the top of the stack is peak. Now what I am telling, now I will be taking the interest. After switch is over, scan %c, interested. While is over, main function is over. This is the end of while and this is end of main. So this while you are writing here. You got it? So you are calling, okay, Case 3 simply you can say peak. Break. Yeah. When you execute this, stack is created. Initially top is -1. Interested is equal to yes. Initially I am interested to do some operation. It asks for size of the stack. Let's say I have entered 5. Now enter 1 for push, 2 for pop, 3 for peak. Let's say I have entered 1. Enter the value 10. Now push function is called. So this is push function. If top is equal to 4, stack overflow. Top is not 4. Top was just -1. S of plus top. S of 0 will be 10. Right. Break. Push function is over. Break. Now switch is over. After switch it is again taking the input. Are you interested to do one more operation? If you type yes, Y, again while loop run, again it will ask enter 1 for push, 2 for pop, 3 for peak. Let's say again I entered 1. Now the value entered is 20. Push. Again you entered Y, interested. Now you entered 2. The choice is 2. Pop function will be called. So you people understood how I have implemented the complete program using an array? Hello? And what are the time complexities? You please look at this code, guys. Did I write anywhere loops or any recursive calls are there? No loop, no recursive call. It is just a conditional statement, output statement, assignment statement, right? So what is the time complexity to do push operation? We can say it is constant time complexity. Similarly, in the pop operation also you see no more loops, no recursive calls. So what is the time complexity we can say for pop? It is also constant time complexity, and even for peak, what is the time complexity? Constant time complexity. It is simple print statement. So using array, if we implement stack, all the operations will take constant time. But with the array, the drawback is we assume when you pop the element is getting deleted, but actually it will not, because arrays by nature they are static memory allocation lists. Fixed memory will be allocated, and that too at compile time memory will be allocated. So that drawback always follow wherever or whatever you implement using array. So guys, today we understood what is a stack, which is a last in first out data structure in which the elements inserted recently will be removed first. And we understood what are the operations on stack. What are the operations on stack? Push operation, pop operation, peak operation. What is the meaning of these three operations we have understood, and we have seen this stack implementation using array. What is the time complexity to implement all operations of stack using array, guys? What is the time complexity we can say? Constant time complexity, big O of 1. Clear? That's all for today. Hope everybody understood what we discussed today in a clear way. And tomorrow we will discuss this topic, simple queue using array. Meenakshi, stack is used in many. One best example, if you are looking for, I can say, see, in the computer there is back button, like you are going from folder to folder, subfolder, subfolder, subfolder. When you click on back, what do you get? The recently visited page you will get. Similarly, when you are browsing certain website you are exploring, when you click on back, what is the recent page you have visited, that you will be able to get. How that is possible? Because it is running in the stack model. See, data structure means it is a organization, it is a method, it is an approach. Data structure means not something which is existing physically. It is a style, okay, approach, algorithm, method. So backtracking is the best example where you see stack nature. And stack is used in the depth first traversal, like as you were asking, I can say applications of stack. Actually our topic is array, not stack. However, as you are interested, I can say stack is used in recursion. Stack is used in backtracking. Stack is used in function implementation. What is the recent function call that is made? After that gets completed only, its caller function will be executed. So in the last in first out order. Stack is used in interrupt handling. Interrupts can be processed in last in first out manner if all the interrupts are maskable interrupts. Maskable interrupts can be processed in the last in first out order. And stack can be used in traversals, depth first traversal. Whether it is a tree traversal or graph traversal. Like this, we have many applications of stack. Okay? Meenakshi. That's all for today, guys. So in the next class, we will be discussing this simple queue using an array. Thank you so much for joining the session. See you tomorrow. Till then, have a great time. Take care. I wish you all a happy learning and happy coding. Bye-bye. Jai Hind.